Good evening, guys. Today I am here with a new lecture whose name is energy transfer, and general energy analysis. So, the first topic is forms of energy. Thermodynamics provide no information about total energy. It deals only with change in total energy. Energy can exist in numerous forms like thermal, mechanical, kinetic, potential, electric, magnetic, chemical, and nuclear, and their sum constituent the total energy. Means the sum of thermal, mechanical, kinetic, potential, electric, magnetic, chemical, and nuclear energy is called total energy. But thermodynamics does not deal with total energy. It deals only with change in total energy. Means at first stage we have energy like 5 joule, and at second stage we have 10 joule of energy. So what is change? 10 minus 5, that is 5 joule. So we deal only with 5 joules of energy change. The next is macroscopic form of energy. If a system possesses as a whole with respect to some outside reference frame, such as kinetic and potential energy, uh, it means that if we have a vessel in which steam or pressurized air or something like that fluid is in that vessel, so at outside we deal with energy, that what is kinetic energy in this vessel and what is potential energy in this vessel. That is called a macroscopic form of energy. The next is microscopic forms of energy. Here it is related to molecular structure of system and degree of molecular activity, and they are independent of outside reference frame. So it means that if we have a vessel in which some fluid is present, and in that fluid we deal with molecular structure of that fluid and their molecular and the degree of molecular activity, and in which direction the molecules are going, and what is in molecule, what is their uh, orbital speed, and in nucleus electrons are revolving. Like this we deal in microscopic forms of energy. The next is internal energy. Internal energy is sum of all microscopic form of energy is called internal energy. Sum of all kinds of these forms of energy, microscopic forms of energy, in which we deal with orbital speed of electron, orbital speed of molecule, spin axis of as a whole molecule, spin axis of electron, translational movement of electron, and translational movement of molecule and atoms, and as a whole they form a microscopic form of energy, and their sum is called internal energy. The next is kinetic energy. What is kinetic energy? The energy that a system possesses as a result of its motion with some reference point is called a kinetic energy. If we say that if here it is molecule and it is going from here to here, it has some speed, so and it has some mass, so we can say that it has a kinetic energy. The next kinetic energy formula half mv square, and its unit is joule. The next is potential energy. The energy that a system possesses as a result of its elevation in a gravitational field. Means if a fluid like water is at some height and we want to extract its energy, as like in turbines, so we can extract its energy by that energy is called potential energy, and its formula is mgh. Here m is mass, g is gravity, acceleration due to gravity, and h is height. So the unit of potential energy is joule. The magnetic, electric and surface tension effect are significant in some specialized cases only, but these are usually ignored. As like in some special cases, these effects, magnetic, electric, surface tension effects are significant, but usually we ignore it. So the total energy is U means internal energy, PE potential energy, and KE kinetic energy. U potential energy formula mgh and kinetic energy formula half mv square. So the unit is joule. If we divide both side with m, and in this equation if we divide both side with small m, so this will become small e, this will become small u, this will become gh, and this will become v square by 2. So it will become a unit mass relationship, means the unit will be joule per kg. In most of the thermodynamics application we deal with joule per kg, as like in petrol, in fuel used in diesel engine, petrol engine, the unit is used mostly is joule per kg. The next is stationary system. Most closed systems remain stationary during a process and experience no change in kinetic and potential energy. Closed system whose velocity and elevation of center of gravity remains same are called stationary system. In stationary system we have a closed system, and that closed system has no velocity, and they remain at their own position, and they does not move in acceleration due to gravity height, and they does not move and they does not move in horizontal direction and in vertical direction. So their kinetic energy is zero and their potential energy is zero, because there is no height change and they have no velocity. So they have zero kinetic energy and zero potential energy. So all of is E is equal to change in internal energy. The next is control volume. Here mass flow rate and volume flow rate is involved. Mass flow rate, mass flow through a section per unit time, means kg per second. Volume flow rate, volume flow through a section per unit time. The unit of volume is cubic meter per second. As we know that density formula, density is equal to mass per unit volume, but in rate, mass flow rate and volume flow rate, we make some dot to represent mass flow rate. This m dot is mass flow rate and this v dot is volume flow rate. So as a whole the formula is this. The next is sensible energy. The portion of internal energy of a system associated with kinetic energy of a molecule is called sensible energy. This kind of energy involves only kinetic energy of a molecule. In latent energy, the internal energy associated with phase of system means if phase change activity is going on, then latent energy is involved, means from ice to liquid water and from liquid to steam the phase is changing, so energy that involved is called latent energy. Chemical energy, the internal energy associated with atomic bonds in a molecule, means the relationship between bonds. They are ionic bond, covalent bond, coordinate covalent bond, or some metallic bond, and they have a sufficient energy is required to break these bonds. That energy that required to break these bonds are called chemical energy. The next is nuclear energy, the tremendous amount of energy associated with strong bonds within the nucleus of atom itself. So in nuclear energy, uranium has a very strong bond within the nucleus. So a large amount of energy will be released if some neutrons are bombarded in uranium atom. Static forms of energy, total energy of a system which can be stored. Energy which can be stored is called static forms of energy, and total energy of a system which cannot be stored is called dynamic forms of energy.